Well guys, welcome to another episode of Kaggle Kingdom. This is Jacob. Today's topic is ScrapeGraphAI, which is a LLM-based scraping pipeline framework. So this is a very cool project, and if you search for Google, you should be able to find their GitHub on this page. And what it does is basically a web scraping Python library that uses LLM and direct graph logic to create scraping pipelines for websites and logo documents. So XML, HTML, JSON, and Markdown. So which is very cool. So in this tutorial, we're going to show you how to build it step by step on Kaggle.com. And that being said, let's get started. So if you go to Kaggle.com, create a notebook, say ScrapeGraphAI, then we create a function that can run bash command within Python because we're going to demo everything on Llama. This framework also supports Grok, OpenAI, Anthropic, and Hugging Face Hub, and more. So, but feel free to check that out. But in this specific demo, we're going to do it on Llama. So let's continue. And so first we have to install Llama using myline command, and after that, make sure you expose Llama host to the 0000 instead of the loopback address. Then you basically have to set the origin to everything, and also spin up Llama using Llama serve, and that's it. So after that, make sure you create a model file so that you can have a bigger context window to run models. And we're going to use Llama 3.2 for the demo. And for Kaggle.com, maybe you choose a smaller model is better than bigger model, because the smaller model basically faster on Kaggle.com. And so after we create a model file, we just do Llama create, use the model file, and create a Llama 3.2 extra context model. So, and if you want to use embedding model, just do Llama pull nomic embed text. So, but in this demo, we're gonna not demo the embeddings. We're gonna just demo the LLM. So which we're gonna use Llama 3.2 extra context model. So then after everything's set up, we'll do a Llama list to show if the model installed correctly. So you can see that the embeddings model installed correctly, Llama 3.2 extra context installed correctly, and also Llama 0.2 original. And the Q1.5, because it's too large, that it will be very slow. But we're going to use Llama 3.2, so it is fine. And after that, make sure that we people install everything, including ScrapeGraphAI, and also Chromium, Chrome driver, and also Nest async.l. This library is needed for notebooks. And also we're going to install Playwright, and then also Playwright install. So that's it. So, and after that, make sure you install the relevant LangChain library. For example, if you want to use Grok, install LangChain Grok. If you want to use Llama, and let's for this example, it will be pip install LangChain Llama. And after that, make sure you upgrade Llama to the latest version using pip install -u Llama. And after that, you can also install some libraries like TensorFlow or Transformers, but those are optional. And then we're gonna apply Nest async.l because this is a notebook, so we do need this function. And after that, we'll just do a graph configuration. So this is a basically scraping pipeline, and it's gonna build on a graph, which is really, really cool. And so we're gonna first define a graph. So to define a graph, we have to basically specify what kind of LLM we want to use. And for this example, we're going to use Llama 3.2 extra context. And then if you want to use Grok, you just define Grok on whatever model you want to use. Then you specify the Grok API key. And in this demo, we don't need the API key because Llama doesn't need the API key. It's installed locally. After that, make sure you install. Also, make sure the token is set to a bigger window. The default is very small, so just set to the default window so you have a bigger token input. And after that, make sure you also set the format to JSON for Llama. And if you have a remote Llama, and you can do a base URL, specify the remote Llama address. But in this demo, it's local, so we don't need to specify the base URL. If you want to specify embedding in the graph configuration, you can specify embedding like that, and then specify the embedding model. And also, we'll demo the search functionality. So we need to specify max results from the search engine. So we just specify it to 5. Also, we have to define the library called beautiful soap. After that, make sure you have less equals to true because it's on Kaggle notebook. So make sure that have less equals to true. We also set the verbals equals to true as well. So after all the graph configuration is done, then we go to the first demo for Smart Scraper Graph. What it's doing is basically a single page scraping. And basically, you can import the Smart Scraper Graph from the graphs package. They define a lot of graphs in this package. So if you go to the GitHub repo, go to the ScrapeGraphAI, and then there's a graphs package. So you can just go to graphs. There's a lot of graphs, but we're gonna demo the ones that they also specify on the README page. So which is the graphs they define in here. So for example, the first one is Smart Scraper Graph. We do single page scraping. So you can specify whatever you want to scrape on that page. For example, this one scrape me all the news from the website. We use the wire.com and we'll pass in the configuration we did earlier for the graph. Then we simply run this graph, and that's it. So you can see this is actually first run in the fetch node, which is the first node in the pipeline. Then we basically run the second node, parse the node, and then generate the answer. So you can see that it's got all the news from that newswire.com. So, and you can see that's very nicely done. It's title, author, and date, and it's really, really nice. The second example we're going to demo is search graph. You can see we basically import the search graph from this graphs package, and then we just define the search graph as list me all the European countries. So we'll trigger the search engine, and we pass in the graph configuration, and then we just simply run this search graph pipeline. You can print the results. You can see that first it will fetch the node and then fetch HTML, parse node, generate answer, parse node, generate answer. So basically, this is a search engine based pipeline. And then you can see the results. The European countries are returned as array and also have these sources available as well. So this is the second example for the search graph. The third one is script creator graph. So to use that graph, you can do a import to use the script creator graph class, and then all you have to do is basically create a prompt using list me all the project within their description. Say this is the GitHub page for a sample projects, and you also need to pass in configuration. What this class does is to single page script that extracts information from a website and then generate a Python script. So after you run this script creator graph pipeline, you basically will be able to get all the information to crawl that website. So for example, the results it's generated in this Python class, and you can see that first it will define function called get projects. The URL is the URL that you're trying to crawl, and after that you just find all the HTML element in this page, because it's actually a single page. So script creator graph is based on a single page, and after you define the function, we just simply do get projects using this function we defined. So this is basically they write a Python function to do the scraping instead of using the default pipeline to do the scraping, which is another way to scrape, and very nice. So, and after that, we're gonna use a different example called Smart Scraper Multi-Graph. So what this does is basically multi-page scraping using LLM. The previous one we basically did a single page. You can see here, and this one is a multi-page scraping. So just import this Smart Scraper Multi-Graph class from this graphs package, and then the prompt is, let's say for example, is who is Marco Perini, and the source is basically we can put all the website or web page we want to scrape, and after that we basically just pass in the configuration. We don't really want to use the schema for now, and after that you can see this is actually crawled very nicely. So you can see the name, title, fields of expertise, and social media links. It's all good, right? So this is a very nice multi-page scraping using the Smart Scraper Multi-Graph. After that, we just also can do the script creator multi-graph. Instead of doing single page and build a Python script or Python function for this single page crawling, We can just do a multi-page crawling as well. So we just define the URLs for these different pages we want to crawl or we want to scrape, and we use this script creator multi-graph class, and then put a prompt here, and also put in URLs we want to scrape, put in the graph calculation, and that's it. And then we can run the pipeline, and then we can get this output. So basically we want to merge this script. So first we have this different scripts we want to store as a file, and after that we just basically merge all the data from different scripts. So this is a way function they defined to crawl multiple pages using a Python function or Python class is generated from this pipeline. And then after all this is ready, then just do a merge script. So that's it. So this is basically a very cool class as well. So it allows you to create a Python function and then to do customized crawling. You can also edit that function, right? So this is very cool. So it's almost like an AI coder type of thing. So, and so the last function or the last sample I want to show you is how to build a customized scraping pipeline. So you can see previous examples are default pipelines, right? So basically you just import this pipeline or this class for the pipeline from this graphs package, but they also provide a way to define your customized pipelines, which is the best or the coolest functionality of this framework. And for example, I want to see how many nodes, default node, it provides in this ScrapeGraphAI helpers package. Right, so have the nodes metadata. So if you just do these keys, then it provides dictionary. So the default, it provides a search internet node, fetch node, get probable text node, parse node, RAG node, and so on and so forth, and also text to speech node, all that. And also you can see the definition of each node using the nodes meta, using the key, and then you can see the description, type args, what it does, what it returns, which is really cool. And for this customized pipeline for scraping, you can basically define something like a first LLM you want to use, and then embedder you want to use. And also you want to define the fetch node. Let's say how you want to fetch the URL, right? You can basically specify the input as this format and output as a doc, and the node configuration, you can just verbose equals to true, or the hello equals to true. And the parse node is basically parse this CRUD XML, right? So you want to parse documentation like that. This is a parse node, and then basically we want to generate answer based on the content, right? So this is basically another node. So after you define all the nodes, you can also define the edges. For example, you define the base graph, right? The nodes are the robot nodes, and also this also detects if the website is allowed for crawling or for scraping. So you define the robot nodes. After that, you can get a fetch node, parse node, and generate an answer node. So you define all the nodes, define edges. First run the robot node, then fetch node, to parse node, and after the parse node, do the generate answers node. Super cool. So define the nodes, edges, define entry point, which is a robot node, and basically then you can run the graph. Just using one prompt, one URL, then you can start the graph, which is super cool. So you and then you got the results, and for the answer, so for example, we just want to describe this content of the example.com. You can see that the description is the domain is for use in illustrative example in documents. So, and also give you URL, more info, super good. And you can also example, let's say for example, want to execute a different website. You can just specify a different website, and you can see that scraping is allowed, even though it didn't get any useful information. But you can see this is also using the robot node to detect if the scraping is allowed for website for legal reasons, which is very good. So this is all the example I want to demo. And for the customized graph or customized scraping pipeline, you can define any node you want. There's a really flexible way to define this pipeline. So that's the best part of this scraping graph AI. So that being said, hope this is helpful. If you do enjoy this video, please subscribe, like, or comment if you have any questions. Last but not least, if you want more examples of the ScrapeGraphAI, you can go to their examples page, and there's grok examples, like a lot of grok examples. There are local models, which is Olama examples. There are Hugging Face examples. And that being said, thanks for watching this video. Thanks for supporting the channel, and I'll see you in the next one.